Hello friends, I'm continuing my journey on building a Tauri app using Rust and React. Today I'll build a small new component which involve both React side code as well as Rust side code. So if I click this button info, so this pop-over is displayed with detailed information about the table. For example, the primary different attributes and some of the other meta information. For that, I'll show how I can integrate this button with a popover component in the UI side. And also in the Rust side, I've called the DynamoDB operation to get the data. And more important aspect I'm going to show today is how I can transform the data written by a third-party crate to my own custom defined crate. And I'll show a very interesting feature to implement the from trait, because you can do the transformation in a number of ways and you can pollute the code. Today I'll show a little bit how to write a cleaner code in Rust, organize the code better in terms of programming, in terms of module structure, and also leveraging the from trait. We can do the transformation and place the related transformation code in one place. So the first of all, if you following me last videos, most of my model or data structure is located in the main.rs. The first thing I have done is creating this model.rs and created this structure inside this file. For example, attribute, item, and so on. So this I am using from the day one. And if you this file name, you can choose anything to give. In my case, I use model.rs. By default, this main.rs cannot recognize model.rs. So we have to give this mod.the file name. Then this model.rs will be compiled and will be part of this particular Rust main project. And to import all this struct I have created, I have used model star. And one more change I have made. Earlier, if you keep this item struct inside main.rs, you no need to specify this access identifier or public, this public keyword. But if you are keeping this particular all model into separate file, you have to explicitly provide this pub, stand for public. And individual field also I make public. So it is up to you. In future, I maybe make it private and provide a getter setter. That is a better way of design the production code, so that your main field is private by nature and you provide a small abstraction layer to the outside world to have a better control. But for the sake of simplicity or ergonomics, I've used all the public, so I can initialize wherever I want a little bit quicker. So for part of today example, I already use this describe table function. This is the Tauri command will helpful for integrating between the React and Rust. And this describe table, we take table name as the input and return this table. And this table struct I have enhanced a lot to have more fields which mirror whatever the information I'm displayed on the screen. If you see the screen, like we have attribute definition, which is of array, and each pair contain the attribute name and type. So for now, we have primary PK stand for partition key and SK stand for short key. So if you define the attributes, one thing important to remember in DynamoDB is that you no need to define all the attributes. So only the like primary key or the composite key you have to define. Rest of the attributes are free flow or free form. You can add whenever you want as your database or your requirement changes. But there is a provision, like when you create a table, you can specify the attribute definition and the type. So if you define that during the creation of table, then all the page will be displayed over here. So this is the table structure, how it look like on the screen. And if you go to this model.rs, this is a little bit laborious process, but it is not complicated. So we have created a table and debug and serialize. Because at this moment, I do not have any requirement to get the data from the React to Rust. If I need the data from React to Rust, then I need to deserialize. Deserialize means converting from JSON to Rust struct. But I have a requirement to return to the React. That means it is serialize. That means converting this Rust type to the JSON structure so that React can consume it. So I need to mention serialize. And I have to rename this all field to camel case. If you notice over here, as per the Rust naming convention, I have separated two words with underscore. But in the React or JavaScript world, we can use, or it is convention to use, like camel case notation. So that during the serialization or during the conversion from this Rust type to the JSON structure, all the attributes should be converted from this snake case to the camel case. And this attribute definition is a vector of attribute definition. So if you see this attribute definition, here also I have to put debug, which will be helpful for printing the information in the console, which is helpful for the development purpose, and serialize and camel case. Similarly, I define a couple of other fields. You can refer to my GitHub code base. I already committed and post the code in my GitHub and given the link in the description below in the video so that you can refer it back. And I have created similarly other fields, for example, table name, status, and other fields. The important aspect of here is that this particular response so this kind of data I got from descript table. If you see, this is the descript table output, and this response contain a field known as table, which will return a table response, table description. If you go back there, so it contains the similar structure. This is a public struct table description. If you follow my previous video, I explained the technical challenge why I cannot use directly this table description as serialize. Because if you see this, there is no serialize keyword, and we can't send as it is to the React world. Let's say we got this data, we can't send as it is this instance of a table description. That is not possible due to there are some technical challenge and this non-exhaustive keyword. This non-exhaustive keyword doesn't allow us to, serialize and deserialize it. And there are some other challenges I explained in a detailed video in previous video. So that I need a transformation from this table description is the third-party crate, this struct to my own format. So if you see this, because this table contain a option type, and I did unwrap and into. This into is very important. It looks tiny, but it is very powerful. So it converts basically this table description from the table description to this table type. This table type is my own type. I define in my model. So this conversion is happened not automatically. Because Rust can't do this conversion for us. So to enable this conversion, this is the magic where it is done. I have to provide a implementation. It is better to give the implementation side by side to the table so that looks handy. So this this is a trait, that into if you provide an implementation this from trait, you can use into wherever you want for converting from one type to another type. So from table description to this table. This table description is the third party struct, and this table is my own struct, which I want to give to the React.js. So if you don't want to do this into, so I have given some another approach in the other function. For example, list items. Here I created a function in this main.rs only, transform item. So if you see this transform item, I put this item, which is represented by hash map, which I got from DynamoDB, and I did all the transformation here and return it back. So either you feel free to do the transformation in this main.rs, or I feel this is a neat way to do that inside model, so that you can use wherever you want. So we have to, once you implement, there is one function, we have to provide a concrete implementation for that. So it looks similar. This arrow notation stands for a generic type, and this is the method argument. Table description is written in a self. Self stands for table. And there is a bit of code over here. I won't go into much detail, but I'll explain one part of it. Let me try to quickly explain this part. So this table description, because I may not know what are the field other things, so I put a debug statement and printed this information and kept in this tmp.txt file. I'll delete this file, but I just put some debug information to see the structure, what is written by the third party crate. So it looks like something like this. Attribute definition, some means it is an option type, and it contains this structure. So I just get an idea about this structure. Once I get a good idea of the structure, I open it side by side. So first from table description, I got attribute definition. It is an option, I have to do unwrap. Because it is a small side project, and I'm in the initial stage, I'm not doing proper error handling. So most of the time you can see me unwrap. So it is not a very recommended approach, but I'm also not sure like how I can handle so many unwraps. Because there are so many places where the third party crate written sum or result. To do proper error handling at all the places, it is a nightmare for me. But I'll figure it out some way as we go proceed forward. But for the time being, I'm mostly using unwrap wherever is I feel like. So from option, I got this vector, this is array, and I am converting to iterator, into iterator. This creates an iterator from a value. Iterator is a kind of one important concept in Rust, which will help us to process one record at a time. It is performance-wise much faster, and from any collection, this iterator is very I created various videos which explain in detail about iterator, but it is basically used to loop through this and deal with this vector or collection in a more optimized manner. Because if you want to directly deal with all the vector and load into memory, it is not a better practice to load all things in memory and do that do duplicate copies. So better to process one by one. And this is the map function. So it is expecting a closure. So this map also again will loop through one by one field and doing some transformation, get this attribute name and type from this attribute definition, and collect finally will convert to the again one more vector. So whatever the type you mention, that it will convert. So this type at this moment is it can't inferred, so we have to provide a proper type over here. So similarly, I create the transformation for all the fields. And one more important field here is that creation date time. Because this is a date time field. If you see option date time, for that I have to add this as a dependency in the cargo.toml file. This AWS Smithy types, whichever the latest version available. And here I use the format method, providing this datetime format. So it will convert, like if you see this example. So RFC 3339. I like here actually the navigation to the source code is really awesome. Whenever I want, because already the Rust mechanism is they have a proper documentation, and I can able to go to the source code for most of the program. So then I can able to understand what is the code it expecting. You know, I can pass those kind of parameters. So it is really very handy to me. So I can provide the datetime format. I don't need to think through it lot of thing like earlier JavaScript, because if it's not typed properly, so I have to spend huge amount of time into understanding which format it need to take, and I have to do lots of googling. But here I know that this is supporting only this thread format, and I need this date format. So this is well good enough. So I can just copy paste its type and pass it across. So this is mostly dealing with the date time. Similarly, I have converted a couple of type, and because if there is no semicolon here, I create an instance of table passing all these values, so it will be returned. And once I come to this describe table, yeah, here also I am returning table. This into will convert this table description to table, and I am returning here. This much part of the Rust code. And let me show you the React code part. All the Rust code will be located in the source.tauri folder. React code is here. And if these types are not very helpful, but I have just created just for in future if I need it, then it would be handy. The same type I created here, I mirror in this index.ts file, table, attribute definition, and all this thing, same as that Rust types. Here describe table, I just have to use this await invoke function and pass this function name and the parameter and cast it as a table. So this filter is the place where I added the button, and to get this popover, I've added this section into the grid. Popover component. Open, close, I'm using a flag. And this is the target. Whenever this button will be clicked, this popover will be displayed. And this is the body. So if I'm using a different React component, JSON prettify. So once I pass this JSON.stringify table data, so then this particular popover will be opened. So once this is the popover, and if you see this is the info button, this is the button, click here. So once we click this button, this set open set, if you see here, this is a boolean state. Open by default is false. Whenever we click, we set it to true. Whenever we click again, we set it to false. So if you see there is a toggle. Initially it is false, we make it true. If it is true, we make it to false. So this open, this is a control component. This is if it is true false, depending upon that popover will be changed. I think on close it should be always false. We can mark it as a false. And this width position I've given, you can control this thing. And this table I'll show you. Whenever the page will be loaded, if the table name is not empty, I calling this describe table and getting this, setting this table field. So this will be the set table state will contain all the fields whichever required for the display purpose. This is a simple code how we can display. and hence the power component is coming into, and we can scroll it down, and so it is all good. So hope you learned something for today. Have a good day ahead. Bye bye.